Good evening, everyone. Myself, Swam Sarup Nanda. I'm present here to discuss a topic that is atomic structure. Okay. Based on the structure of atoms, atoms are mainly classified into three types. That is, there are mainly three types of atoms. They are solid, liquid, and gaseous atoms. Okay. Solid atoms, for example, we can speak. Solid atoms are this one is a solid atom, solid bottle. We can pretty easily hold it within our hand, and uh, going after that, liquid. Okay, example we can take water. The water we are drinking is a liquid atom, so that we can drink it. And for example, gaseous atom, like gas, there are many gas. The air around us is a gas. So these all are the examples of solid, liquid, and gas. So moving after that, uh, there are two main concepts regarding the atomic structure. So I'm going to explain about the two concepts here. The intermolecular space, the intermolecular force of attraction. What it does mean? Intermolecular space. That means the space in between two molecules of an atom. Okay. And the intermolecular force of attraction. That is the foundation force that closely bounds that atom within each other. That is known as the intermolecular force of attraction. Okay. First, also comes the solid atom first. Okay, in solid atom, the intermolecular space. Okay, the intermolecular space is very negligible. How? Here the space, if the space is not negligible, can I hold this atom? Okay, I cannot hold this bottle within my hand. So in a solid atom, the molecules or the atoms are firmly bounded with each other, so that I can hold it very easily within my hand, within my palm. Okay. Like here also, the solid, if it falls from here, it will make a sound. You can hear this sound. Okay, this one is the sound. If the atoms are closely bound to each other, if it also falls from a height, it will not disturb the intermolecular space. The atoms will be present there as it was present before. Okay. Then moving on after that, the liquid atom. In liquid atom, I have given you an example. Water is a liquid. Okay, like in water, the molecules are bounded to each other, like we can see the water. So that, because in water, if the molecules are not bounded to each other, we cannot see that. Okay, we can see that, but it is not as much as compared to solid. I'm explaining that one. Like in solid, the atoms are closely bounded to each other, and the space is very negligible, and the force is very high. In liquid, the atoms are not as much closely bounded to each other, and the force of attraction is also not as much as solid. So that the atoms of liquid can move from one point to another easily. Like if I throw water from one place to another, it can reach somewhere else. How? Because the atoms are not closely bounded to each other. Okay, explain this. Then after that comes the gaseous atom. Like I have given you an example of air. The air around us is gas. So the atoms present in the gas can freely move among each other. So the space is also negligible, and the force of attraction is also negligible. I am explaining that the space is very much high in gaseous atoms. Okay, I'm wrong that time. I will explain that the force of attraction is very low and the space is very high. Okay, how? I'm giving an example of a deodorant bottle. Okay, like if we're spraying a deodorant, the fragrance of the deodorant can be smelled, like there is a range within which it can be smelled very easily. How? When we spray the deodorant, the atoms that come from the deodorant bottle pretty easily infuses within the air, and the air acts as a medium to carry those atoms from one place to another. So in a gas atom, the molecules are not closely bounded to each other, and the force of attraction is also not like that. Okay, where was I? In gas. So in gas, the intermolecular space is very much high, and the intermolecular force of attraction is very much low. So from all these points, we can conclude a fact. Can you tell that one? I am speaking. Like there is a equation: intermolecular force of attraction is inversely proportional to the intermolecular space. Like if the intermolecular force of attraction increases, the intermolecular space decreases, and if the force of attraction decreases, the space increases. So here I'm concluding my lecture now, and thanks a lot, students, for participating me, or I hope this lecture will be pretty helpful for you in your future. Thank you.